projects. In this video, we are going to explain about the project title Brain Tumor Detection Using Convolutional Neural Network. Before explaining the execution, let me give you an overview of the project. Brain tumor segmentation is difficult in medical image processing due to the wide variation in appearance and the similarity between tumor and normal tissues. Tumors can exhibit diverse shapes, sizes, and textures, making it hard to accurately distinguish them from healthy brain tissue. The project aims to improve tumor detection accuracy and efficiency, reducing reliance on time consuming and error prone manual interpretation of medical images. The project employs CNN, Convolutional Neural Network, trained on labeled medical imaging dataset. CNNs are a type of deep learning model specifically designed for processing visual data like images. By training on annotated datasets, the CNN learns to recognize patterns in features indicative of brain tumors. These patterns include variations in intensity, shape, or texture that distinguish tumor regions from normal brain tissue. Once trained, the CNN can analyze new medical images and provide predictions on the presence and location of tumors with high accuracy. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, backend framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used to implement this project, we have utilized the following algorithms. The first algorithm is KNN, K nearest neighbor. KNN is a simple and effective classification algorithm that classifies data points based on the majority class among the nearest neighbors. KNN is used for classifying brain tumor images based on similarities with labeled images in the dataset. Coming to the next algorithm, which is logistic regression. Logistic regression is a statistical method for modeling binary outcomes using a logistic function. Logistic regression is utilized for binary classification tasks in brain tumor detection, such as determining the presence or absence of a tumor in an image. Multilayer perceptron. MLP is a type of artificial neural network consisting of multiple layers of nodes, neurons, including an input layer, one or more hidden layers, and an output layer. MLP is employed for more complex classification tasks in brain tumor detection where non-linear relationships between features need to be captured. Navy Bayes. Navy Bayes is a probabilistic classification algorithm based on Bayes' theorem with the assumption of independence between features. Navy Bayes is applied for classifying brain tumor images by estimating the probability of a tumor given the observed features. Random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and outputs the mode of the classes, classification, or the mean prediction regression of the individual trees. Random forest is used to improve the accuracy and robustness of brain tumor classification by aggregating predictions from multiple decision trees. Coming to the next algorithm, which is SVM, Support Vector Machine. SVM is a supervised learning algorithm used for classification and regression tasks. It constructs a hyperplane or a set of hyperplanes in a high dimensional space to separate different classes. SVM is applied to classify brain tumor images by finding the optimal hyperplane that separates tumor and non-tumor regions in the feature space. Decision tree. Decision tree is a tree-like model of decisions and their possible consequences. It breaks down a dataset into smaller subsets while recursively partitioning it based on the most significant attribute values. Decision tree is used as standalone classifiers or as components of ensemble methods like random forest for brain tumor detection tasks. Coming to the next algorithm, which is voting classifier. Voting classifier is an ensemble learning method that combines multiple individual classifiers and aggregates the predictions by voting. Voting classifier can aggregate the predictions of various classifiers like decision tree and random forest to improve the overall performance of brain tumor detection. CNN, Convolutional Neural Network. CNN is a deep learning algorithm particularly suited for image classification tasks. It consists of multiple layers, including convolutional, pooling, and fully connected layers, designed to automatically learn hierarchical features from input images. In the brain tumor detection project, CNN is the primary focus as it excels at learning intricate patterns and features indicative of tumors in medical imaging data, ultimately leading to highly accurate tumor detection and segmentation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the dataset folder. In this dataset folder, we are having two more folders named No and Yes. In the No folder, we are having MRI images of brains with normal tissues representing cases without detectable brain tumors. And in the Yes folder, we have the MRI images of brains with tumors or abnormal growths representing cases with diagnosed brain tumors. These images will be trained using the algorithms to distinguish between brain MRI images with and without tumors, ultimately aiding in automated tumor diagnosis. In this folder, we have the test cases which we will use in the front end. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, home.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flash framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flash framework. If we are a new user, we need to register first. So click on sign up button here. Here we need to enter all these details to register. But I have already registered. So click on I am a already member. So here we need to enter the username and the password which we have registered and then click on login. We have logged in successfully and we are redirected to the production page. So here we need to upload the brain MRI images, and after uploading the images, the application will predict whether the person is diagnosed with brain tumor or not. The uploaded image should be less than 500 KB in size. Click on Choose File to upload the image. So here I am selecting this image. So here we can see that the image is uploaded. Now click on Upload button. This is the uploaded image and it is predicted as the patient is not diagnosed with brain tumor. It means that the person is not having brain tumor. Click on Try again. Let us upload some more images. I'm selecting this image. This is the uploaded image and it is predicted as the patient is diagnosed with brain tumor. It means that the person is having brain tumor. Let us upload some more images and check whether the person is diagnosed with brain tumor or not. This is the uploaded image and it is predicted as the patient is not diagnosed with brain tumor. Click on Choose File. I'm selecting this image. Click on Upload button. This is the uploaded image and it is predicted as the patient is diagnosed with brain tumor. Let us upload some more images. I'm selecting this image. This is the uploaded image and it is predicted as the patient is not diagnosed with brain tumor. In this way, just by uploading the brain MRI images, we can predict whether the patient is diagnosed with brain tumor or not. Click on Sign Out button here. The project concludes that convolutional neural networks (CNNs) are highly effective for automating brain tumor detection from medical images, improving diagnostic accuracy and efficiency. This underscores the importance of deep learning approaches in medical image analysis with potential for further advancements in healthcare applications.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.